In TensorFlow, hidden layers are an essential component of neural networks, which are used for various machine learning tasks, including deep learning. Hidden layers are intermediate layers in a neural network that exist between the input layer and the output layer. They are called hidden because they are not directly observable or part of the input or output. Their purpose is to learn and represent complex patterns and features within the data. Pradeep K. Suri, author and researcher. Here's how hidden layers work in TensorFlow. One input layer. The input layer of a neural network receives the raw data, which could be features from a data set. Each node in the input layer corresponds to one feature. Two hidden layers. The hidden layers, which can consist of one or more layers, come after the input layer. Each layer contains a set of neurons, also called nodes, that perform computations on the input data. These neurons apply weights to the inputs, perform an activation function, and produce outputs. The outputs of one hidden layer become the inputs to the next hidden layer in the network. 3. Weighted sum. Each neuron in a hidden layer computes a weighted sum of its inputs. These weights are adjusted during training to learn the patterns in the data. 4. Activation function. After calculating the weighted sum, an activation function is applied to introduce nonlinearity into the network. Common activation functions include ReLU, rectified linear unit, sigmoid, and tan. The choice of activation function depends on the specific problem and network architecture. 5. Output layer. The final hidden layer is followed by the output layer, which produces the network's predictions or classifications based on the information learned by the hidden layers. In TensorFlow, you can define hidden layers using its high-level API, example keras, or its lower-level operations. Here's a simplified example of creating a feed-forward neural network with hidden layers using TensorFlow's keras API. Python. Import TensorFlow STF. From TensorFlow import keras. Hashtag create a sequential model. Model equals keras.sequential. Hashtag add an input layer. Model.add, keras.layers.input, shape equals input underscore dim. Hashtag add hidden layers. Model.add, keras.layers.dense, units equals hidden underscore units 1, activation equals ReLU. Model.add, keras.layers.dense, units equals hidden underscore units 2, activation equals ReLU. Hashtag add the output layer. Model.add, keras.layers.dense, units equals output underscore dim, activation equals softmax. Hashtag compile the model. Model.compile, optimizer equals atom, loss equals categorical underscore cross entropy, metrics equals accuracy. Hashtag train the model. Model.fit, x underscore train, y underscore train, epochs equals epochs, batch underscore size equals batch underscore size. In this example, keras.layers.dense represents fully connected, dense, layers, and you can adjust the number of hidden layers, the number of neurons in each hidden layer, and the activation functions to suit your specific problem. The number and size of hidden layers, along with other hyperparameters, are crucial factors in determining the architecture and performance of your neural network, and they often require experimentation and tuning to achieve the best results for your specific task. Thank you.